Hello, everyone. Very excited to be here with all of you. My name is Bilgin. I'm the engineering manager for PyTorch on device. And I have Mergen with me, who is the tech lead on PyTorch on device ML. And today we've got some exciting news for everyone. And we'll be covering the ExecuTorch 1.0 release. This is our general availability release that we've been building together with you folks over the past few years. And ExecuTorch is PyTorch's on-device AI solution. We have been building ExecuTorch to enhance privacy, right, by making your data stay within your device. For example, you can do translations for WhatsApp, right? It improves the latency by making sure that the data is not requiring to do that round trip to the servers, improves the costs, saves the cost by running these ML workloads at the edge rather than those expensive GPUs. It gives you remote access without requiring networking, and a few other reasons for doing on-device ML is, especially on the LLM side, on GenAI, the models are getting smaller and they're getting smarter. What a larger model used to be able to do a couple of years ago are now available with much smaller models on the edge. Those are some of the benefits of on-device ML, but there are some fundamental challenges as well that we have to solve for. Battery life and power is one of these. With these tiny devices, it's very easy to drain the battery. These edge devices also have a lot of memory constraints, memory bandwidth, thermal constraints. It's very easy for your classes to heat up when you're running these workloads on the edge. And the hardware heterogeneity, right? We have multiple different chipsets, and the need to optimize for each of these platforms is a big challenge. To solve for those challenges, we ground up built ExecuTorch, and with ExecuTorch, we're able to stay within the same PyTorch ecosystem, from authoring all the way to deployment. You start with your PyTorch program, and with torch export, we're able to do full graph capture, and with progressive lowering, we're able to get that PyTorch model into the edge devices. And without requiring any conversions or rewriting, we're able to solve for this problem. A couple of examples on showcasing some of the simplicity, some code snippets. Ahead of time, it's as simple as instantiating your model and exporting the model with torch.export, and then later stages you can send your program to edge. In this particular case, we are using the XNM pack partitioner to utilize the CPU accelerators that we have, and finally you're writing your program into the flat buffer. On the runtime side, with the given model file with 4 lines, you're able to up your model file and create a example tensor and simple module forward. You're able to get your inference. We're giving some examples on the C++ side. We have the same simple APIs on the Swift side for iOS, and we also have the similar simplicity on the Android side with Kotlin as well. Some design principles I'd like to emphasize. Hopefully, most of these are not news. We wanted to make sure that ExecuTorch is portable, right? Supporting a wide variety of edge platforms. from powerful mobile chipsets to embedded systems. And performance, we wanted to make sure that the runtime is lightweight and with strong partnerships with the hardware partners, we've optimized the performance as well. Productivity, staying within the PyTorch tool chain, making sure that you are able to go all the way from authoring to deployment without necessarily needing these sometimes awkward conversions and debugging experiences. These were some of the design principles. Obviously, we wanted to do this in open source with the community. That was the driving factor for us to release ExecuTorch 2 years ago with an MVP. Wanted to build it together with you folks. And modularity, we're providing well-defined workflows for PyTorch programs, from capture to transformations and execution with out-of-box components. In terms of the timeline, just giving a little bit more history, started with the MVP. This was mostly to gather feedback and, again, build ExecuTorch, the stack, together with all of you. Shortly after that, we've added Llama support in our alpha release. This is when LLM support in ExecuTorch started picking up. And we improved our SDK quite a bit. There were a lot of delegate enhancements. And last year, during this conference, we provided some strong performance numbers on LLMs. And we gave some early adoption stories. And we also provided some API stability. And today, finally, after all of that hard work, we are going to be going through some of our ecosystem integrations. We're going to talk a little bit about adoption. We have strong adoption. We're going to talk, we've improved the backend coverage and reliability, and we'll give some of those examples. Without further ado, again, as of today, we are generally available and with multiple success stories. I'll start with some of the internal adoption. ExecuTorch is integrated into all of Meta apps. It is integrated into Facebook, WhatsApp, Instagram, and Messenger. It is powering multiple different use cases, serving billions of inferences for billions of users. This required a ton of reliability and hardening work. It not only powers the family of apps, it also powers our RL headsets and smart glasses. There are multiple use cases that we are running on the Oculus headset and Ray-Ban smart glasses. For external success stories, we've partnered with Liquid AI, Private Mind, Nimble Edge, and multiple models are getting served by these external partners. There are a number of ecosystem integrations with software mention. They integrated ExecuTorch and have built React Native ExecuTorch, serving multiple users of theirs. We've partnered with Hugging Face to increase the model coverage through Optimum and Torch.io for interoperability on the quantization side, Onslaught AI, Ultra Analytics, and MediaFlare for on-device training, and Digica for a number of use cases that they're supporting. And these ecosystem integrations and adoptions is only increasing. And we expect a lot more. Another area that we have improved since the beta release is the backend coverage. We have XenAMPAC with ARM Clyde AI for CPU acceleration, Apple Core ML for Apple Silicon, and Qualcomm AI for the Qualcomm Hexagon MPU, ARM EthosU for MPUs, and Vulkan GPU. These are all production-ready, serving multiple use cases for Meta. There are a number of other backends that we have added over the past 6 months to a year: ARM VGF, NXP for Neutron MPUs, Samsung Exynos for Exynos and MPUs, OpenVINO from Intel has been added, and Cadence DSP, MediaTek NPU, Apple MPS. We'll continue to harden these delegates and make sure that they are serving millions of users as well. A few more features before I give it to Mergen that we have developed for the general availability. As I mentioned, one of the key areas where we worked hard for this release was reliability and hardening. Serving billions of users and multiple use cases for different variety of hardware is no easy task. ExecuTorch is now at meta scale, able to scale and provide that reliability. We've got strong coverage and performance guarantees thanks to the Qualcomm team over here on the Qualcomm engine backend, especially on LLMs. Some of those numbers are going to be available on our website. With the ARM, on the ARM side, Clyde SME2 enabled, and multiple use cases run efficiently on low-power ARM EthosU. And we've also added Windows support and improved the UX for build and Swift PM and Maven builds. We've added program data separation, and for example, you can run LoRa, which was a long requested feature from us. Torch.io interoperability, this one is also quite important for us because we are now able to run multiple quantization algorithms like HQQ. And we also added an experimental feature for doing JavaScript and browser support via WASM. And yeah, there are multiple other features that we've added, but without further ado, I'm actually going to pass it to Mergen so that he can go through some of the demos.
Thank you, Bilgin. Hey, my name is Mergen. So as Bilgin said, ExecuTorch is a general purpose runtime. Whatever you can write in PyTorch, it can be lowered through export with minimal work. And these are some of the example models we have, the LLMs, the computer vision models, the speech models, and so on and so forth. So let's just maybe take an example of a multimodality. If you think of multimodal, the architecture is relatively standardized now. There's the audio encoder or vision encoder. There's the projection layer and maybe a decoder layer. And we are basically trying to standardize it along with the Hugging Face Transformers library and be able to export it to ExecuTorch in a very compatible way. So you can use a one-line script to run it. For instance, Voxtrel is an audio modality, audio inputs modality that you can export to ExecuTorch. And on top of that, you can just use that in your runtime directly using the three types of API, Java, C++, and Swift in iOS. We have a few demos. Let's just pick this one. So this is running Gemma 3 4 billion parameter. This is a vision and text input model. And what it's doing is that it is taking an image as an input as well as a text as an input. And then it is running on XenAMPAC on ARM CPU with Clyde enabled on this one. So this is a memory bandwidth bound. So as a result, the prefill is by fundamentally it is slow. But when you all right, okay, all right.
There we go.
So once it actually is able to prefill it, the tokens decode is roughly 8 to 9 tokens per second. All right. There will be a few of these kind of demos throughout the. Oops. So this is a Voxtrel. So describing audio. I don't have the audio file. This one I'll upload it into the slides later today. But you are trying to basically speak to the phone, and then it's describing describing the interaction between two people here. So this is a comedic conversation between two men, possibly friends. So talking about tattoos. Yeah. All right. Oops. LoRa, this is a common request we've heard from people. So the idea is that you basically create a foundational model. Let's say you use Llama as a foundation model, and then you have two data sets. You fine-tune it, let's say in this example, one for Nobel Prize winners from 2025. Llama was not, like this is after Llama launched, so Llama doesn't have the information. And another data set for ExecuTorch tutorials. And in this case, we are showing you can load two LoRa adapters together simultaneously without incurring extra memory or binary size load on the code. So, so what? So yeah, so here, so this is the adapter specifically for that is trained for fine-tuned for ExecuTorch tutorials. All right. All right. So these are some of the demos we have. You can go to our website and look at more of the success stories and demos. And I want to talk a little bit about what we are thinking for 1.1 and beyond in the future. And we worked so hard until now, but we still want to actually do more things in the future. The first one is we have 12 backends as of today, and 4 of them are production ready. So we would like to actually continue working on the 8 remaining backends to be production ready. And on top of that, ecosystem. So ExecuTorch, we think of it as a low-level library. And I do think a natural step is in there where the middle layers or higher level like middleware layers, that is more for instance, modeling libraries or SDKs can be integrated to ExecuTorch directly there. So maybe in the robotics space, in the IoT space, the mobile space, right? So the next one is desktop, laptop. We've been talking about the edge. One thing that's the big elephant in the room is like, all right, can you run on gaming PCs, right? Can you run gaming PCs with CUDA backend? And a lot of people are doing this kind of local type of inference on gaming PCs. We've seen with inspired by Llama CPP and MLX. These are great runtimes that we've learned a lot from it. So ExecuTorch traditionally don't have CUDA, but until now, we have, and so let me just show maybe.
Dancing in the masquerade, idle truth in plain sight jaded. Pop, roll, click, shot. Who will I be today or not?
But such a talent as moving seems asleep.
So this is a poem, and we are basically running this poem in. Let me just running this poem on the Windows on RTX 580 with completely no C++, completely no Python dependency or libtorch dependency. And then the prompt you are asking is like, how is the speaker feeling right now? It's specifically chosen because, compared to Whisper, for instance, you can't do that through Whisper. It doesn't convey emotions. But with this demo, we were able to retrieve a bit about the emotions of the audio. All right, so we have 3 minutes. So let me. So these also demos will be available in the portal. So Gemma 3 is available as well. We also enabled Whisper directly here. So what is that? Just this morning we enabled it. So
Mr. Quilter is the apostle of the middle classes, and we are glad to welcome his gospel.
So this is a transcription. So let's see whether it is able to transcribe on a consumer laptop. Yeah, the Mr. Quilter is an apostle of the middle class. So yeah, it is able to transcribe pretty quickly. Yeah, so we have numbers so far. This is by no means a final number. This is, we've been, if you, for instance, look at it, it's 50 tokens. If it's quantized, 90 tokens, all close to 100 tokens for Whisper, 170 tokens. But I do think this is a very early but very promising direction. So the idea is that this is a model agnostic. So instead of focusing on only LLMs or only vision, you can actually do anything model agnostic. Like Whisper is available, ResNet is available, right? So we have demos on these. And stay in the PyTorch ecosystem. No Python runtime is required, so you can actually run in this native C++ environments. No libtorch, so you can save on binary size. One thing that PyTorch already has the CUDA backend available, so we do not want to reinvent the wheels. So we are using the compiler technologies directly and then actually interoperate with ExecuTorch and validate on Windows and Windows WSL and Linux so far. Yeah, it's still early, but very promising direction, and we're so excited about this direction to be going into this new market of AI PCs. Also, we're currently experimenting on a similar approach on MacBooks too, so leveraging Metal GPU by using AOTI. So this is another example where Voxter example of running Voxtral, but use the kernels from the PyTorch core and use it directly from the MPS Metal backend and compile it and be able to do inference. So this is audio prompt that captures identity change. So anyway, we have another numbers for this, still early, just enabled it yesterday. Thank you, Manuel. All right, so I just want to step back. We talked about ExecuTorch 1.0. Really, this is mobile and embedded is really the bread and butter of we are going to continue working on mobile and embedded systems. And I just want to say, first of all, thank you to all the partners. I see so many familiar faces in this room, and I'm glad that because of the collaboration, we are able to successfully announce ExecuTorch GA. And I also want to thank the teammates of PyTorch Edge for working really hard to come to this place. Thank you, everyone. Thank you.